Hello, welcome to Answer Everywhere. Today we're taking a look at some source code. We're taking a look at GNU Grub, the bootloader that I think pretty much everyone uses to boot into Linux. So I don't know anything about this code, the code base, how it's organized. It's hosted on the GNU.org website. I didn't see a great mirror of it on GitHub. So I'm going to look at it in Emacs, which hopefully will be fun and exciting and acceptable. So first of all, this is the wrong. What are you doing, Treemacs? Can I untreemacs? Okay. So we have grub core and include and po, which will be like translation files, tests, and themes. And then Unicode and util. What are tests? There's a lot of tests. I don't know what a .in file is. Maybe these are the test suites. This looks like a bash script. We have set being called. I don't know what build shebang is. Maybe it changes based on the various shells. But this seems to be a bash-based test. And maybe these are all shell tests. Sys Linux. I don't know how you would maintain such a large suite of shell tests, but I guess they do. Yeah, skill anyway. All right, so they have a lot of tests. That's good. I'm not sure how I feel about shell being used as the test framework, but maybe they don't have a lot of choice. I'm guessing everything is either in grub core or assembly tests. Assembly tests, let's just take a quick look. Should we look at PowerPC, Spark 64, or i386? I guess i386. Old Clang doesn't support .code 16, so we have .code 16 and some move B instruction. That's the only thing we have here. And then in Arch, we have whatever syntax unified is. And some Arch, I guess this is maybe saying that the architecture is ARM v7A. And then whatever this thing is. So I don't know what these things are doing, but these claim to be some sort of assembly tests. Include, I'm going to guess, is mainly the home of header files. So we have multi-boot 2 and multi-boot. I don't know if multi-boot is maybe an old name for Grub, or if this is a separate project. And then the Grub directory does seem to be mostly all of the headers. And we probably get this directory structure repeated in grub core. Let's take a quick look at utilities. There are a lot of utilities. We have things like bash completion, get root, grub file, grub install, grub reboot. What's the one you call when you change grub? Is it grub install? I guess this is just some utility that's going to call grub like libraries or grub methods. So let's take a look in grub core and try to figure out where we want to be. We have part tool, which I'm going to guess is something about partitioning. Term tests. Term, I'm going to guess, is terminal stuff. Morse. Is this Morse code? Da is O. What is S? S should be short, right? D. O should be da. Yes, this is Morse code. Why is it Morse code? I'm not sure. Register output audio. It sounds like Grub can output Morse code. Is this for real? Huh. I'm assuming this is mostly a joke, since this is a new feature. Does it support Morse input? What year is this? Using the system speaker. 2017. Let's ask the AIs. Does Grub support Morse code? You don't know. You don't know ChatGPT. Let's see if Gemini knows about it. This is a, yeah, okay. What other Unix utilities support Morse code? There's a command line tool called Morse. All right, great. I don't know why we need Morse code, but it's there, I think, mostly as a joke. We have other things. ARM, I'm going to guess, is support for the ARM architecture, although who knows? Where does ARM appear here? Grub/ARM/cross. Cross keyboard. Compatible with Google and cross keyboard. I don't know what that is. What is PL50? I don't know. All right, so that is that's something of a mystery. We have script, term, video, colors. I'm going to guess video is in the sense of like graphic output. In general, we see what's probably a frame buffer, EMU, maybe emulator, core boot, and so on, and some bitmap stuff. I/O, I'm going to guess, is mainly utilities, like buffer I/O, gzip I/O, LZ. So like, I guess writing to a buffer, writing to a buffer compressed with gzip, writing to a buffer compressed with LZ. I don't know what offset is, but, and then similar for XZ, if you like the XZ attack. Kern has a lot of stuff, including ACPI and buffer and command. And main. Is this the only main we have? Oh, whoops. I forgot that I have to actually provide the name, the find flag. Let's try this one more time. Yeah, okay. So we have several names. We have Grub normal main, and then we have main in kern and kern emu. I don't know what normal means. Normal has auth, auto fs, character set, color, completion, main, and menu. I'm going to guess normal/main may be the most appropriate starting point. But let's take another quick look at the folders up here. Boot seems important. Decompressor, i386, MIPS, PowerPC. I feel like i386 has to also include 64. I'm not sure if maybe they are separate, or if they have the same like boot stuff. We have PC versus QEMU, which is the emulator. So let's look at QEMU, boot.s. This appears to be assembly, right? I guess, I don't know. This seems like assembly syntax. We have start. I don't know anything about assembly. This seems to be defining some sort of variable. I'm guessing this defines a long 0. Although with what name, I don't know. And then doing some XORs with registers, I suppose, and moving stuff around. Set up the real mode stack. So this is somehow we know that to boot, we have to set some stuff up. Ultimately, we should be doing what? Since we're booting, we should be like pointing to where in memory the operating system is, right? Move grub memory machine real stack. ESP, set up the real mode stack, transition to protected mode, and it says we use push L to force generation of a flat return address. What is real to prot? Something we're jumping to. And we ensure A20 is enabled. We're in QEMU. So control port A works, and there's no need to wait since there's no real logic. It's all emulated. And we're going to include this kernel real mode stuff. Intel, in its infinite wisdom, decided to put the I-8086 entry point right here. And this is why we need this kludge. So I don't know what org grub boot machine size -16 means, but at some point we jump to _start and whatever this boot machine size is, I guess maybe it's something that's being passed to the jump instruction or along those lines. Okay, so jump to start, I'm going to guess, is the thing that actually causes it to start running the operating system. What jumps do we have in here? So let's see if we can find where start is defined. So we have a bunch of start implementations, which is not surprising. There's a bunch of tests, or maybe these are just all tests. But let's look at the... Okay, here we have, in x86-64, we have EFI and Zen. Are those the only ones we have? Yeah, let's look at EFI. But let's look at this EFI stuff again. UEFI is... So EFI came from the Itanium era in the 1990s, and they felt that things were too restrictive, such as real mode, a small addressable memory space, assembly language, etc. And so Intel made this thing called EFI, and they open sourced a version of it in Tiano for a minute or two. Okay, so that's not so bad. Thanks so much for letting me know. And so the advantages that we have for EFI are the ability to boot a disk containing large partitions over 2 terabyte with a GUID partition table. So this is the standardish Linux partition table. I don't know if this is the only one. The standard layout for partition tables of a physical computer to storage device using universally unique UUIDs, which are also known as globally unique identifiers. Okay. So this is the, all right, so this is like the standard partition-y thing. And so we have the ability to boot, I guess, larger disks, flexible pre-OS environment, including network capability, GUI, multi-language. So this, I guess, is where, I'm not sure. I don't know if this is like, is this post BIOS? It replaces BIOS, which is present in the boot ROM of all personal computers. Okay, so I guess this is like the thing that you boot up here. Is this UEFI? So this stuff, the fact that you can now click around, I guess, and stuff is from UEFI, if I'm understanding correctly, because it has GUI capability. We have the pre-OS environment can be either 32-bit or 64-bit. You have this. You can program in C as opposed to assembly. And you can have a Python interpreter. And it's just generally more flexible, I suppose. Okay, so that's what's up with EFI. I guess it is the same as UEFI. And then real mode, also called real address mode, is an operating mode of all x86 compatible CPUs. The mode gets distinct from the fact that the addresses in real memory always correspond to real locations in memory. Okay, so this is like untranslated, I guess. Is that right? So it introduced protected mode, blah, blah, blah. Required a new operating system, blah, 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 blah. Okay, I'm going to guess that real mode means basically you are, there's no like indirection. Okay. So that tells us a little bit. At some point we get to grub main, which I think was just called grub underscore main. I'm going to guess that's in the normal file. Well, let's see if we can find it just with grep. These are, I think, essentially jumping to there. Here's emu main.c. And then here we have what appears to be the definition in the kernel header, the start point of the C code. So let's see if we can find its implementation. What did I do? Okay, oh, it just jumped to the implementation. Okay, so here's grub main. We are in what? Grub core / kern. The main routine. So we're going to call grub machine init. First of all, initialize the machine. I don't know what the machine is. I guess they're modeling it as some sort of virtual machine or Turing machine or whatever. And then we call boot time after machine init. I'm guessing this just records the time or something like that. Well, let's try looking at the struct. Boot time stats. Okay. I'm going to guess it's just recording boot time. And then we have some modification to break flicker-free boot on EFI. So disable it there. So we have this hello stuff where we set the terminal color and say welcome to grub, and we print out some stuff. And then we initialize verifiers. I don't know what a verifier is, but I'm going to guess it's going to like check, sanity check your environment. Then we're going to load your config. And then we'll call grub boot time again. Okay, so grub boot time, you pass it a string and it's just gonna like log or record some message about when that thing happened. I don't know why that's not called log, but it essentially seems to be some sort of logging utility, at least broadly thinking. Then we register exported symbols. Load preloaded modules and free the space. Okay, I don't know where we're registering them, but we're registering them. We may have some arch DL init linker stuff. Then we're going to load the grub modules, do more logging, set prefix and root. I'm going to guess this is the root file system. Is that right? No comment. How about we open up the kernel? Where's the kernel header? The machine-specific prefix initializations. We have nothing in the header about it. Okay, so we get no comment about what that's doing, but I'm going to suppose it's essentially handling the file system. Actually, we can look at it on the right-hand side here. So the variables that we have are device path, FW device, FW path. I'm not sure what FW is in a prefix, and some module header. And then we're going to register the variable root and whatever this thing, the environment right root. Then we're going to get the boot location from the passing in the FW device and FW path. And if we have an FW device, I'm going to guess this function must populate these variables. Then we compute the command path, calling this printf thing. And then in the grub environment set, we set the command path. And if we have a prefix, then I guess we do some prefixy stuff. String dupe. Okay. I don't know if that's like the root only during grub, or if that's like the OS root, but I guess it doesn't matter so much. Where did my other version of main go? Okay, so that was what, the prefix thing? And then we export root and we export prefix after we've computed them, or rather set them, I guess. Then we reclaim module space. I don't know if modules are done at this time. More logging. We register the core commands. And if we have a loaded config, now's the time where we parse and execute it. And then we load normal mode. I guess that's what the normal directory is for. And then we call rescue run. I'm guessing that normal mode might fail and rescue run runs if normal mode fails, which I think many of us have seen happen. So load normal mode calls grub dl load. DL, I guess, isn't that like the Microsoft term for a library? And then we print any errors, and then we call command execute normal. What is DL load? I'm gonna guess this. Oh yeah, this is just some module. Load a module using the symbolic name. Okay, so we load the normal module, and then we execute the command that says do normal stuff. And execute command is a general command using the command pattern, I suppose, where we pass in the name of the command and some arguments and some variable arguments. And we create we pass in a string command, and then we create a type system understandable command, the grub command T. And then we do some sort of search for the command given the string. And if we find it, then we look in the command's function and execute it. Otherwise, we return some sort of not found error. And so this command, grub command T, is presumably just some struct that has a function pointer and some metadata, but let's take a look at it. Grub command T. We've got this export func macro. Oh no, this is defining some function that returns a grub command T. Okay, and it's grub command T is type deft from grub command, and we have a next and a previous. So maybe this is the list of all the commands, a name, a priority, and a function, and some flags, and a human readable summary and description. And then you can just, if you have needs for more stuff, you have this void star data thing that you can use at your will. Okay, so this is starting to take shape as far as what we're doing. What do we know at this point? Well, we know that the way Grub is organized is we have a bunch of, for each architecture, we have some assembly files that has essentially handwritten assembly that the authors of that code know how to execute the boot sequence on those architectures. That assembly sets up whatever needs to be set up and then calls grub main. Grub main, ignoring things like logging, starts loading modules and executing commands, the last of which is essentially normal. And then I guess if normal fails, you get this rescue behavior. So what does normal mode actually do? That's the next thing to check. We have auth. How are we doing auth? Auth user. We can register authentication. Grub auth authenticate. You pass in some user, which is a car star. And we get the current, we have this variable for the current user. And we call named list find grub as named list of users on the user that we passed in. And we set that to cur. And if cur is not set, then we allocate it, I guess. And if we can't allocate it, we have an error. And if the user is authenticated, oh no, we set user authenticated to 1. And if the user doesn't have a name, I guess, then we set the name to the user, the contents of the user variable. And then we free cur, and we return a grub error. Oh, no, rather. So we set, we set it here, and then if that fails, then we do the error. And then we push the current onto the list of users. So this doesn't actually seem to do any authentication. It just like adds a user, right? And then deauthenticate, I'm going to guess, is basically removes it from the thing. And to register authentication, you give it a user and a callback, an auth callback, and a void star argument. And we're going to look for the user, I guess, possibly do error handling, set the current user's callback to the callback that's been passed in, set the current args to the args that were passed in. And if we can't, if we don't have a name, we're going to do the name stuff. And if we get all the way to the bottom, we'll say that there's no error. We have this deauthenticate, which I think we looked at, and is authenticated, is presumably just going to do what? Oh, no, maybe not. We're going to give it a user list. Is authenticated. We give it a whole list of users. And we are going to create a list of super users, I guess, and a grub auth user. And then from the grub environment, we're going to get the super users and set the super users variable to that. If we don't have any super users, we'll return 1, which I'm going to guess is not authenticated. I don't know. Otherwise, we're going to loop over the elements in users. And if they are not authenticated, then we continue. And if we're down here, then user list and grub store word, stir word, user list username, or grub stir word user, super user's username, return 1. So if we get down here, the user that we're at the iteration of is authenticated. And so we check that it's in string word, user list username. We want to make sure, I guess, the user's in the user list, maybe. And the user name is in the super users list, I think. And if so, we return 1. So maybe 1 means authenticated. And if we're down here, return 0. I'm not sure really what this is about. This doesn't seem to like do anything really authentication-y. Oh, wow, look. This is the British spelling of authorization, isn't it? English speakers from outside the US and Canada use authorized. Okay, so it's not just British. It's like everyone outside of North America. All right. By default, the Grub bootloader interface is accessible to anyone with physical access to the console. Anyone can select and edit any menu entry. And direct access to the Grub shell prompt for most systems, this is reasonable, since anyone with direct physical access has a variety of other ways to gain full access, and requiring authentication at the bootloader level will only serve to make it difficult to recover broken systems. However, some systems, some environments, such as kiosks, it may be appropriate to lock down the bootloader to require authentication before performing certain operations. Password and password PBKDF2 commands can be used to define users, each of which has an associated password. Okay. Password sets the password in plain text, requiring grub.config to be secure. Password PBKDF2 sets the password hashed. All right. Okay. So in order to enable authentication support, the super user's environment variable must be set to a list of usernames separated by any of spaces, commas, semicolons, pipes, or ampersands. Well, that's a lot of flexibility. So that can't be good. It can't be like a good idea, I feel like, to have an underspecified syntax for which people are allowed to access your secured environment, can it? All right, if super users is set, then use of the command line and editing of menu entries are automatically restricted to super users. Okay, so that's what I think this, I was confused about this authentication if super user is not set. So what this was doing, somewhere there was an if super. So if not super users, this is checking, and it's saying if the environment variable is not set, then we allow anyone access. Okay, and so, but I don't know where we did any passwording. Here we go, check authentication, but who calls this? Grub command authenticate. Okay, so I guess when you enter a command, we're gonna call grub command authenticate, and that's where we have this, we pass in a user list. And I think we're gonna ask for a password. Yeah, here we go. We're gonna call puts to ask for our, a username and ask for a password. Okay, good deal. This is like the the password system you would implement if you were like, it's I guess you wouldn't do things that way. That's a little bit like if you were implementing it as like a school exercise. But I think that you're in such a restricted environment that maybe that's a sensible thing to do. I don't know. At any rate, let's go to main of normal mode. We have this normal free menu. I'm going to guess this is just freeing the menu. By freeing maybe all of the entities in it or something along those lines. Read config file get line. Helper for read config file. So you're going to pass it in a line, in attribute unused, and data. And I guess you're going to try to find what's in that line. We have this grub menu type. Oh, sorry, read config file is going to return a grub menu type. Let's see what the grub menu type is. Has a size of a menu and a list of entries. I don't know why we've got this type def struct pattern. We've got this underscore type, and then we're type defing. I'm not sure which side the asterisk belongs to in type def, but I think that what we're doing is type defing a grub menu entry t as a pointer to this other type, and we're doing this for all of the like main types. I'm not sure if that's just because that's the easiest way to get a pointer type or something to a struct. At any rate, a grub menu entry has a title, an identifier, whether it's restricted, and if it's, I guess we have users for if it's restricted, I suppose. And then a class, the classes are associated with the menu entry, used to choose an icon or other style attributes. And then we have some source code of the menu entry used by the editor. And then parameters to be passed to the menu definition and a hotkey in a submenu. And I don't know what source code is, but basically they're like doing arbitrary code execution, it seems like. Let's see if we can find references to source code. We have the script execute source code, and commands menu. I'm going to guess menu is where we want to be. Menu entry, I mean. So this is adding the source code. I want to see what executes it. I think this is all just adding and freeing from the source code. Grub arg option. Add menu entry. Yeah, well maybe it's the script thing. Script execute. Helper for grub script execute source code. We pass it in a line and some data. We set the source to data, and we have this pointer thing. If we don't have a source, we do some error stuff. str car. Is this just looking for the car? Yeah, I think so. I think this is some sort of search for the character function. So we're looking for a new line. And if we have it, then we take that as that's like the line of code, I guess. Otherwise, we do what? Set line equal to the, just duplicating the source code. So I guess since we had no new line, we have concluded or inferred that source is only a single line. And so we just set line to that. And then we may move along the source pointer. But that doesn't actually execute anything, does it? Execute source code. Is this what I just saw? Oh, sorry, that was get line. Fine. So execute source code. You pass in the source. We have a variable for the parsed script. And while we have the source, we call get line, and then we call the script parser, which will return the parsed script. If we don't have it, we do some error handling. Then we call grub script execute on the parsed script. And this is ultimately calling script execute command. And ultimately, it seems like we're calling command the exec. The exec function on the command itself. Okay, so it seems like the source code we're passing in is mainly like essentially a pointer to a function that Grub already knows how to execute. Is that right? Where's the parsed source code stuff? Yeah, so once we have the parsed script, we are calling execute command on the script command. And the command has some sort of function inside of it, right? That it can execute. And then is it worth looking at the parsing command? Parse the script passed in script and return the parsed data structure that is ready to be interpreted. So we've got some lexing going on. And yeah, this is a pretty small parser. I think we're just, the script I think is ultimately like C code. And somehow we are just figuring out which functions we're going to call. And where's this, the data structure? Parsed. Grub script. So a grub script has a reference count, I guess, some script memory and a script command, and some block arguments. So let's see if we can find some grub scripts. Hey. Do I think that reading the code of a library or framework is good for beginners? I don't know. It's a good question. I think it probably doesn't matter. I think a library or framework, well, a framework is usually larger. So it's kind of up to you. If you want to read a particular thing, then go at it. If you are asking because you feel like you should and you don't really want to, then maybe just pick something smaller. That's what I would say. Okay, so whoops, whoa, I'm not gonna print that out. So grub config is written in Grub's built-in scripting language, which has a syntax quite similar to that of GNU Bash or other Bourne shell derivatives. A word is a sequence of characters considered as a single unit by Grub, or it is separated by meta characters, which is basically white space and the following: curly braces, vertical pipe, and $, semicolon, and the angular brackets. And then we have some reserved words like case for case analysis, do, done, elif. This is, a lot of these are familiar from Bash, as is this thing. All right, and we have some quoting. Okay, so it seems to have some real script stuff. I don't really know. Let's see if we can find, just out of sheer curiosity, the folder that has more scripting stuff. Do we already see that script? Okay, so here's a script folder. It's got a parser, a function, that the implementation of the script function calling stuff. Okay, so we have a legitimate script. This is like the Lexer definition, I assume. Yeah, okay. So that's fun. That's probably a small enough script programming language thing that it's easy to keep all in your head at once, relatively speaking. All right, then back to normal, we have crypto, which I'm going to guess is mainly PBKDF2. Or not. Grub crypto autoload. Or maybe this is more for like encrypted disks. We're including grub crypto.h. Crypto autoload may want some buff.io of file systems may want crypto models. It may result in infinite recursion. Hence this check. So we check for depth. Crypto spec free. Read crypto list. Crypto.lst. Let's find out what that is. The internet seems to think it's for disk encryption. Here's Debian stuff. What if we just try grub crypto? I'm going to guess that the main thing is grub with crypto enhancements. Crypto mount. Set up access to encrypted devices. I'm going to guess this is for encrypted devices. I don't know what else this would really be, but I don't see anything that makes it obvious that that's what it's for. Read crypto list, read file system list, read command list. This is the read list commands. I'm back in main.c. I think we already looked at normal execute, didn't we? Or maybe not. Read the config file, execute the menu interface or the command line interface if batch is false. So if we're not nested, then we get the environment prefix, which we saw computed in some other function. Then we're going to read the list from the prefix. And we just saw the read lists function that read like the file systems in the crypto and some other stuff. And then we have some register variable hook prefix. I guess you can add in some hooks here. Or maybe this is adding its own hook. I don't think it's calling a hook. It seems to be registering some hook. Read lists hook. So we're registering some read lists hook, I guess, and we just read the lists. Then we do some logging, essentially. And then if we have a config, which should have been passed in, then we read the config file and ignore any error. And if we are not in batch mode, then we check that there's a menu and the menu has its size. And we show the menu. And if we're nested, then we call normal free menu. Let's look at show menu. This is mainly error handling around show menu. And we're probably just going to put some stuff, right? We call run menu, menu get entry, E, So run menu, I'm going to guess, is where the user selects something. You get a boot entry back, and you call grub menu get entry on the boot entry and get some E. Whatever grub class is, close. If auto boot, then we try to boot it, right? So we pass in the menu E auto booted, an execution callback and a notify boot kind of callbacky function, it looks like. Otherwise, we call menu execute entry. And then let's take a look at run menu. Show the menu and handle menu entry selection. Yeah, so this is where the user selects a menu. How are we showing it? Get entry number menu default. If default entry is not within the menu entries, fall back on the first entry. And then we have some timeout where there's no timeout. The countdown and hidden styles result in the system doing nothing and providing no or very little indication why. Technically, this is what the user asked for, but it's not very useful and likely to be a source of confusion, so we disallow this. If there is no timeout, okay. So if there's no timeout, we suppress styles. Okay, so at any point, there's generally a timeout. We have some coordinate, which is the position. I'm guessing that's where you are in the menu. And some timeout stuff. While one, we get key no block, grub term no key. I don't know what this stuff is. Something we seem to be looking for interrupts and hotkeys and stuff, and making sure that if timeout happens, then we select something. But I don't see where we printed the menu. Shows the menu and handle. Okay. I'm not sure. Somewhere there should be some sort of like, so we're getting time. I don't know. We can print the timeout. This seems to be, we're like switching on input and handling it. I don't know. Somewhere we show the menu. Not really sure where it is. I don't think it's get timeout. I don't think it's get entry number. Maybe it is get entry number. All right. It's somewhere we do it, and I'm sure it's essentially some print function. But I'm not going to search anymore. So term, what is term? We have some term state. Something about printing UCS for real. Print more. Normal reset more. Put code. So I guess this is largely like printing, setting color, that sort of thing. Putting stuff to the terminal. Okay. And then we have completion, command line. How's command line different from terminal? I don't know. Maybe these are like command line arguments. We have grub history. So I guess you can look up in history the stuff that you've done. Print completion, command line term, and so on and so forth. Okay. I feel like we have a pretty good idea about what grub is up to. We have also fonts and file system stuff. Let's look for, so we have Btrfs, X2, FAT, Minix, Squash file system, XFS, RiserFS. Let's look at FAT as a simple file system. So we've got some attributes like whether it's read-only. I don't know what hidden means in this context. And some like volume ID. And then we have a grub fat directory entry. This is some just model of the fat directory, I guess. And then long name entry, etc. And some stuff about sectors. So it seems to be like almost a full implementation, which I guess maybe makes sense because we don't have an operating system yet, right? So Grub somehow has to have implementations of all these file systems. Is that right? Here's Btrfs. Do we import anything? We import zstd and mini LZO. Yeah. Seems like there's a lot of the work. HFS. So HFS should be the Apple one, right? Or is that HFS Plus? And we don't seem to be importing any Apple stuff. So it seems like these are like from scratch implementations. File system grub. So I'll ask the AIs, does Grub have its own implementations of the file systems it supports? Like Btrfs? Yeah, I don't. It's a good question whether it's similar to the Linux implementation. I'll pull up some Linux stuff. So Gemini says no, Grub does not have its own implementations. Reduced code size. Okay, so how does Grub access? Let's see. So what does Grub actually need to do? It's like, what does it need to do with your file system? Well, if you have some boot partition, it needs to find where your like VM Linux thing is, and it needs to find your grub config on a Btrfs file system. How does it know how to navigate the file system? During the boot process, even before grub loads, the BIOS may have rudimentary Btrfs support. Leveraging init-rd. In some cases, boot process may involve an initial RAM disk. Fallback to the device scanning. Limited interaction. I don't know. It seems like there's some implementation here. I think you're just not correct. Okay. All right. So let's find out more about init-rd. So init-rd is you can load a temporary root file system into memory to be used as part of the Linux startup process. Init-rd and init-ramfs refer to two different methods to achieving this. Both are commonly used to make preparations before the real root file system is mounted. So many Linux distros ship with a single generic kernel image. The device drivers in the general image are included as loadable kernel modules. Yeah. Yes, blah, blah, complications. The image of the initial root file system must be stored somewhere accessible by the Linux bootloader or the boot firmware of the computer. This can be the root file system itself. Yeah, so we have, even if we use init-rd, we need to load init-rd, right? So how does grub load init? I think Gemini was the one who was telling me about init-rd. How does grub load init-rd if it doesn't understand the file system? Only needs to recognize basic file system structures and signatures. I'm not sure what that means. It seems like it needs some code. So let's look up the how about file system? I think Torvalds is the GitHub repo. How about just Linux? Let's see if there's fat.h. Okay, so we do have this fat file system stuff. And we have this struct of mount options. And a struct of more other things. Some inode info. This is all kind of metadata that's in the header. And then a bunch of methods. Fat make mode, make attributes, check summing. And then Unix also has its own, like there's the POSIX file interface. It has things like opening files and stuff like that, which Grub doesn't need. And maybe that's what the AIs are trying to tell me. But it does seem like it needs some representation of all this stuff. Because how else really are you going to get the stuff that you need from disk? So let's see if we can match any of this stuff. Dir. We have MS-DOS dir entry. I don't think I can click on this in GitHub though. So an MS-DOS dir entry has a name, attribute, lcase, ctime, CS, etc. So that should all be the same, right? Do we have secondary count? We have ctime, mtime, atime. That's all reasonable. Do we have a checksum? I'm not sure. They seem to be modeled maybe slightly different. I don't know if MS-DOS dir entry is different from a fat dir entry. But these are somehow related. So I think that basically what I'm going to believe is that Grub just really has as little implementation as they need to be able to navigate the file system, open up things, and find the files it needs. Let's see, is there open? Grub fat open. Let's look at grub fat open. So you pass it in a file and a name. Name of what? I don't know. Or maybe you get the name out. And we set found to null. And we create an error that we can possibly return. And then we set the disk to the file. And then we get the device, then we get the disk. Then we call grub dl ref on my mod. What is my mod? I don't know. Then we call grub fat mount on the disk. And if we have no data, we go to fail. And then we have this help node thing and set the root to be a bunch of stuff. We set .data to data, .disk to disk. We set the attribute to grub fat attribute directory, indicating that it's a grub fat directory. File size to 0. The file cluster is the data root cluster. I'm guessing that's like a fat thing for where the file starts, etc. And then we call find file lookup, etc. So we do have the ability to open up files, etc. Let's maybe look at mount, grub fat mount. And I thought for a second this was going to be a general mount, but this is just fat mount as named by the function name. Okay, so it's got some at least rudimentary file system support, which is pretty interesting. And then disk it's got to have some similar stuff like ATA. You have crypto disk. I don't know what Gelly is. Host, LVM, loopback. Looks should be more crypto stuff. LVM is logical volumes. RAID 5 and 6 recover. I'm not sure what the recovery process is, but maybe something to help you recover if you're trying to boot and you have some problem with your RAID array. And Skizzy. So they have to kind of support all of this. Why don't you use VS Code? VS Code is fine. Why don't I use it? I just prefer Emacs, I guess. I've used it a little bit before. But I just prefer Emacs. I think I'm going to stop there. We're about an hour and 15 minutes in. So that's Grub, or at least the part to the Grub that we got to in an hour. And we saw, I think, a lot of it. We saw the startup process where we start from some assembly that's tied to the individual chip. That assembly hands off to the C code that now we're in C, which is a kind of generalized assembly. The C code is well organized, like easy to navigate. That was all very pleasant. And it essentially just starts, it provides you with a menu. It has like a command pattern structure where one of the commands is just like sets up normal mode, and if normal fails, it seems to fall back. And then the thing that normal mode seems to do is it provides you a way to, you have these grub entries, obviously, and then those entries are essentially parameterized. We didn't really see a lot about this implementation, but they're going to have a thing like, where's my init RAM init image? Which kernel am I booting? What are some of the parameters that I'm sending to Linux? Assuming that it's Linux, that they have support for other systems as well. And then it has the things that it needs to be able to like find stuff on disk, like the Linux kernel and the RAM image. And it also has so not only the disk is in the physical layer, but also the file system layer. And that's really a lot of what it does, other than outputting the Morse code, which is a little known function, I think. So I'm gonna stop there. I see. Can I please do some graphs stuff next? Probably not next, and I don't know what you mean by graphs, but we have looked at some graph stuff, including graph databases, and at the moment, I'm not taking requests because I have a big backlog. I think I'm going to start taking requests again relatively soon. But I'm working on how that's going to look. So I'm going to stay on. I'm going to look at another repo, but I'm going to take maybe about a 2 to 3 minute break